Good afternoon, everyone who's joining us today. We're back again with Grady Gobongo. He will be taking us through a journey of Python as he's been doing so far. For those that don't know who Grady is, he is a techpreneur and is focused on innovation. He is interested in building solutions that improve productivity for students and young researchers. Uh, Take it away, Grady.
All right. Thank you, Cindy. Hi, everyone. Welcome back. And today we're working with predictions. So as you saw from the topic, it says from data to predictions, regression and classifications with Python. It might sound a bit confusing. Some people don't actually know what that's about, but I'll take you through it. So to be quite honest, this was one of the most complex things for me when I was learning. So I'll try my best to break it down so that everybody understands. Hence, I've even created some slides because you need to understand the concepts around it. You need to get the logic because the code is very complex. I won't lie to you. Even I get it wrong sometimes, but we'll make it work. So I'll just share my screen and get started. Great, here we go. I believe you can see my screen. As you can see, I have my IDE open. We're very familiar with this interface by now. This is PyCharm where we will be writing our code. But let us start off with our slides. So from data to predictions. Let's start off by going through the agenda. So this topic covers what we call machine learning. It covers models, it covers regressions and classifications. We have things that we call features and targets. We have splitting the data, evaluating the model, and then the actual Python code. So these are the very important things you need to know when you want to work with predictive analysis in code. But let us get into the details of this so that you understand. And in simple terms, let's start with machine learning. So machine learning, it's basically that is teaching a computer to learn from previous examples so it can make predictions about new data. And a real life example maybe can be a teacher after marking 500 exams, they notice that students who study more get better marks, or students who attend class regularly usually perform better. So without realizing it, you've learned a pattern. So a computer can learn the same pattern. So yeah, basically that's how machine learning works. And now we have models. Before I jump into this, I want to take you into the model. So a model basically is simply a computer program that is learned from data. So you've probably heard of so many models that do this, that do that. But if you have, for example, an example I can give is hours studied. As you know, our data set is about student performance, their grades and all that. I actually have it open here. So for example, if we have students that studied 2 hours got 45, those that studied 5 hours got 50, those that studied 7 hours got 80, those that studied 9 hours got 92. As you can see, the more you study, the more marks you get. So if a student studied 6 hours, 6 hours was not in our data, but the model is going to say that if the student studies 6 hours, they might get the mark between those that studied 7 hours and 8 hours, which is about 70 something. So basically, that's how it works. And now let us go through regression. Let us start off with regression. So regression is usually for me, it was the hardest concept, but I'll try and break it down to make it very easy. So regression is used when we want to predict a number. And numbers, it can be floats, it can be full integers. So basically it can be numbers with decimals or whole numbers. So regression, it's just dealing with numeric values, numbers. So imagine maybe you have a fruit shop, and one apple costs 5 rand, two apples cost 10 rand. So if you want to buy 4 apples, you can predict that it's going to cost 20 rand. That's regression. So just keep that in mind. It's just numbers. And classification. Classification, it's groups or categories. So it predicts groups or categories. It doesn't work with numbers. So an example I can give you is pass or fail, yes or no, those type of examples: male, female, sick, healthy, poor, excellent. That's classifications. So it's categories and groups in our data sets. Now, I want to move on to features and targets. Am I still audible? My computer seems to be frozen.
You're fine. We can hear
You're
you.
audible, Grady.
Okay.
Grady, we can't hear you now. Grady, are you there? Hello? Okay, I think Grady is having a bit of a network problem. But we have a comment.
Cindy, can you
Oh, he's
hear me?
back. Yes, I can.
Okay. Okay. You can hear me, but
Your screen hasn't changed, no.
mine. But yeah, screen hasn't not like it's frozen. But anyways, features and targets. Hopefully it loads by the time I finish with this part. Features, it's the clues we did, attendance, sleep, previous scores to test. And those are just inputs, or rather columns we want to work with. It's the clues we give the computer. And our target is the output, what we want to predict. So basically, our output can be either
Okay. Yeah,
yeah, it's not moving at all.
Grady, I lost you. We lost you again. Yeah, maybe close the slide, but you're saying it's frozen.
Yeah, no tabs are working. I don't
Mhm.
know if I could just quickly restart and rejoin.
Gradis, restart it. Just restart.
Yeah,
Gonna
all
Yeah,
right.
let's
correct.
restart.
I can just quickly restart and
Okay.
rejoin.
Yeah, these are the perks of working on a virtual space. Such things happen.
Yeah.
We'll give
Grady,
you a
please
minute,
just
Grady.
Grady, please just hand over the hosting to me, please. Oh,
I'm not sure if I'll be able to do that because I'm not able to actually do any clicking.
all right. Let's just
Okay, great. You just restart the whole thing. It will correct.
yes.
By virtue of Grady leaving space, you become automated host, methods tree. All right, while we wait for Grady, feel free, because I understand today we have some data scientists, like Jane, for instance. Would you like to share with us your experience of using Python? Any tips for us social sciences? How best to approach it?
Cindy, you want to trip me off my feet?
I mean, you've worked in the space for a while now. I mean, we could
Yeah,
use
but
the
actually, it's
space.
not for. Yeah, you're right. I'm gonna share. If I were trying to help Gradis solve the
Yeah.
problem, yeah, I'll be delighted to share. Though
Uh-huh.
basically we work not on social science, but you
Mhm.
know now on computer related
Yeah.
issues. But lately, we are working on quote extraction,
Oh,
and
okay.
you know, it's more or less related to psychologists. Yeah, because when we're talking of quote extraction, we're looking at the span,
We're looking at
the
the
span, the test span of the
test
quotes.
span. Okay.
Yes, and the surrounding environment. That's the context, not just quote. We're looking at the context.
Mm.
And yeah, and that's where social science comes in.
Mm-hmm.
And of late, we are trying to correlate the two,
Okay.
computer science and social science. Yeah, if you talk of the span, trying to understand the span, you are more or less talking about the social science aspect of the work. So, in the course of the work, these things revolves around natural language processing.
Yes.
Basically, yeah, they're all natural language processing. And then of late, by the little work I've done with Prof, I've learned a lot about how the two can, inter, can intercept, where they intercept here. So
Mm.
of late, I'm no longer be talking language of computer science, more or less. I'll be talking more of social science because you see where two of them meet.
Mm-hmm.
So we got to know of late that if the context in a quote of late, the modern approach will be RAG. You must have heard about uh, RAG model.
Raglan.
Yes. Yeah, you must have, right?
Mm.
RAG.
Yes, yes.
And both computer scientists and social science are using RAG now. Is that the
Maybe
architecture?
maybe define it a bit for the audience because some of us may not know rag.
Oh, is that what you're saying? Oh, I'm
Briefly,
there. I will
yes.
do that. Yeah, because I'm excited though to share my experience because when you share your experience, you know that you like what grad is doing. I'm also happy because that was what I was taking over there. I was teaching the master student how to
Ah,
do data to prediction, from data to prediction. So I'm basically happy that you people are working towards that. So based on your question, the RAG model. Or,
Would be the best for social sciences.
both social science, like I told you, you have come to see where two of them. I'm talking about retrieval augmented generation.
Yeah.
Yeah, it's
Okay.
dominant deployment
I
architecture
see.
for large language models now.
Philosophy.
You must have
Okay.
heard about LLMs now. Do you? I guess you have.
We have, yes.
Gravity. Yeah,
Yes.
yeah. So the rapid rise of RAG has the dominant deployment architecture for LLMs now. So retrieval augmented generation is now the state of the art, because when we are looking at the context, we saw the work of 2025 work on RAG model. And when you test it, you subject it to various tests, it's top notch. The result is awesome. So we're beginning to we're beginning to see that RAG is predominantly dominating large language models. So
see.
for now, let's hold on. We'll still talk so that Grady can continue.
We
Right.
will
I said,
definitely have you share more with us soon in one of our coming up streams. But I understand that Grady is back. Let's hear more
oh,
from maybe Grady, you
that,
can jump into the
yes.
demonstration and we will
Yeah.
upload the slides onto YouTube.
Right, Grady, please.
Thank you so much, Jane, for that insight.
Thanks, my dear. Pleasure, always.
Grady, are you there?
Yes.
Okay, great.
Thank you.
Let's jump straight to our demonstration. We'll cover the slides on our YouTube channel.
For sure. So I'll definitely send the slides through so you get the concept. But let me head over to PyCharm. So what we're going to do now is actually use the logic that we would use for predictive analysis and apply it. So the first thing is importing all our libraries. So as I've written the script already and I've put some comments there just so we know what that library does or what that piece of code does. So we insert our libraries, and these libraries are very important because they do different things for our predictive analysis. So for example, this first one splits the data sets. This second library works with the regression model. This one works with the classification model. And the last one works with evaluating our model because it needs to evaluate what the code did and whether there were errors, the accuracy rate, and all that. So as we know, always we need to load our data set, which is our student performance file.
Yes.
And we need to I always like to view the first 5 rows just so I know that the data set has been loaded onto my IDE. There we go. I can see the results from the data set. So what you want to do now is you need to make sure there's no missing values, especially in the columns you're going to use. So as we worked on the data the last time, we know there are missing values. I showed you this the last time, but we need to cut these missing values because we cannot train a model with no values, if you get what I'm saying. So we need to make sure every row has a record. So what we need to do is we need to sort of clean this data. And what we're going to do is we're going to replace missing values with the columns average. So I'll put a column here. So basically, replace missing values with the columns average. which is what I'm going to do in this code here. So this is these are the columns we are going to use. These are the columns we're going to use. And from the slides, these are the features. This is what we're going to use to do the predictive analysis. So these are the features. So me running this code, it takes all the missing values and replaces them with the average column. So as we can see, our features, which is the most important value columns for this analysis, have 0 missing columns. Now we will jump straight into regression. So I created separators as well. So regression. So what we want to do is we want to select all the features. We want to select all the features, and our features are going to be in the variable called X here. So all these features are being selected from our Excel file, which is our data set. And we need to place a target as well. So the target is our output, and our target is our exam score. So we are predicting exam scores from the features that are here. So basically from the attendance, from the sleep hours, from the tutoring sessions, we want to predict exam scores. So our X, our input, Y, output, mathematics. Great. So we need to now split the data. We need to make sure we split the data properly. So I will insert a block of code here, and I will also explain to you the most important part of this code. So what I mean by splitting the data is when you have a data set, you need at least 80% of the data to train the model, and you need the other 20% to test the model. So basically, it's like teaching. So you give the students tests, you give them exams. I mean, you teach them like 80% of the work, and the rest of the 20, they must sort of like figure out. So it's something like that. You need to test the data set with 80. You need to train the data set with 80%, or rather you need to train your model, sorry, with 80% of the data and test with the remaining 20. With that remaining 20, you still have the actual values in the data set, so you can also compare, which makes it easy for you to tell whether the model is working accurately. So that's what this does here. So 0.20, that's 20 is basically the 20%. So if I put it at 30, that's 30%, etc. So I will run this code here. All right, so it tells us here, if you look down here, it tells us that the data is being, or rather the model is being trained with 5,284 records, and it's going to be tested with 1,322 records. So about 20% of our data. So it's going to be tested. Now, we need to now use our actual libraries to train the data. Control C. Sorry. Yeah, so linear regression, it's a library. So basically, it's a library built in Python. And this is what we're going to use to train our data, the regression model. So I will quickly run this as well.
While you're running that, by saying it's part of the library, so there's no computing for me.
No, all you have to do is import. You need to make sure you just import the library from the start, and you will have everything. So here, yes, I have the process finished and regression model trained successfully. So what I want to do now is I want to make the predictions. I want to make the predictions. So let me make this a comment. So I want to make the predictions. I want to make the first 10 predictions.
And what does that mean in lay English? What are you looking to predict?
So I'm looking to predict the exam scores from the data I have. So basically, okay, I will need to look for my data set. So in my data set, I obviously have these columns here. I have these columns, which are my inputs here. And I've inserted these columns as this is what I want to use to predict an exam score. I used 80% of the data set. So I used about 5,000 records in the data set to train it. So it basically picks up a pattern the same way you would be like, it's the students that study more hours that get more marks. The model picks up the same pattern, those exact same patterns. So it goes through those 5,000 records, it picks up a pattern, and it's like, okay, I understand it now. So now I want to test if it's actually working. So the remaining 1,000 records, it does not have, what's this? It does not have predictions for them because it was not trained on them. But what I want to do is I want to test it. So I want to test it with the remaining 1,000 records. I don't have predictions for them. So I want to now create, no, what's this? Sorry. The model has not been trained on these 1,300 records. So I want to create predictions for them and then compare with the actual scores to see if it was trained properly. I don't know if that's making sense.
Makes absolute sense. Thank you.
Yeah, so these first 10 predictions, I just want to test if the code learned, if the model learned. So it's giving me this output. And right now we are still not sure. What if they are wrong? What if they are right? So that's why we're gonna insert another block of code to now compare the results. We wanna see if these predictions are the same as the actual results or at least close based on what you've given it, which was all the data that was used to train it. So I'll grab that. I'll just call it compare here. Compare. All right, there we go. So now we have the actual exam scores versus the predicted ones. So for this student, they actually got 69. But after the predicted score was 69.71. I mean, the model did not receive this data. It just predicted based off what it was given before. It probably picked up pattern from all the factors that we gave it, which are these factors above. So we can see that the scores are quite close. We have 67, 67.66. I mean, here we have 62, here we have 63. That's slightly off, but it's close. I mean, it's not, we don't expect it to be accurate. It's a prediction. So we need to also evaluate the model. So if I'm not mistaken, yeah, so I think you're gonna take a look at this to understand the evaluations, because it's we call it MAF, so it's mean absolute error. It's used in regression, and basically it's like the difference from the actual score and the predictive score to actually see how much error our model has. So in this case, if you take all these scores and you get to an average, you will see that the model is off by 1.26. So that's the error. That's the mean absolute error, as we call it. So basically, it's like the difference between the actual score and the predictive score. So, I mean, the model is quite good, but it can still be improved. And it's quite tough to get 0% error. All right, so what we're gonna do now, we can also predict new students. So new students that come into the class, you can now predict maybe their scores from the previous students. I will put in a block of code here. Run it. And now we just see that predicting the new students' predicted exam score is 67. So now I think it makes sense that the student gets 67 because almost the whole class is averaging between 60 and 70. I mean, if you look at their scores here, also if you look at the data set, which I'll need to look for and open, but I don't want to take much time. If you look at the data set as well, you'll see that many students are averaging that score. Actually, here we go.
Will you share your data set on our YouTube so that we can try it out ourselves?
Yes, for sure. So even in the data sets, if you look at the score column, you see that many students average around the same mark. So the model predicts that a new student coming into the class will get around that score based on what it has been trained on.
Yeah.
And yeah, let us move to classification.
Okay.
So what we want to do maybe is we want to see how many students passed, how many students failed, or want to predict the pass rate, the fail rate. So the logic is quite simple. When you put it in English terms, it's just a condition that says if your mark is above 50, pass, or else fail. And as you know, with Python, you write those the logic, you write it the same as the code. So as you can see here, it's just if score is greater or equals to 50, pass, else fail. So it's just the way you write the syntax that's different, but that's the condition. And with classifications, it's just categories. So you can create so many groups or categories, pass, fail, yes, no, male, female, depending on what you want to do. And then we just print out that output. And yeah, it displays a couple of students, let's just say 5 students, and pass, because all their marks are actually above 50. And if we had a student that has a mark below 50, then it would have failed. So basically, that's how classifications and regression works. It's a bit complex to write the code, but once you understand the logic, it becomes quite easy, especially if you know the logic and the concepts behind it. Everything else becomes a bit easy.
If I want to learn how to write the code, but I don't know how to, where can I get support? outside of
I think,
methods tree, of course.
yeah, so starting off, you will want to know how to first code the most basic things. So there's a site called W3 Schools. That's where I actually started learning Python. Well, I was learning Python in school, but that site is what helped me because yeah, sometimes I would miss some things in class. But you learn the concept, so they teach you things like actually assigning lists or arrays, stuff like this. You need to know how to actually assign an array. You need to know how to assign variables. You need to know how to print something. So once you get all that, everything else becomes easy because, as I said, it's all about the logic first. Once you know the logic, you will know how to write the code. So when you know the concepts or how to write lines of code, once the logic comes, you know how to put it.
Okay.
Because it's like plain English. It says, if I tell you write a code that says, if I get less than 50% pass, if I get more than 50% fail, you write it as is, but in code because you know how to write that if statement because you learned it. So it's stuff like that.
Okay, Grady, thank you so much for your time today and rising above our connectivity challenges.
Yeah.
Do we have any questions for Grady? If you do, please feel free to unmute yourself and go ahead.
All right. Thank you so much, Grady. That was a
Thank you
beautiful one. You're doing well.
so much.
I'm
Appreciate it.
excited because my time is not wasted. I actually came here to do something very urgent. But when I saw the post, I don't know whether it's in Cindy's. Yeah, I saw it the other day. I went to my gallery. I quickly registered just like about a few minutes ago. So I'm not
Oh,
regretting my being here. So, first of all, there is this place you said random state 42. You never told us why the random state, though you explained the test. So let me start there. What about that random state Y42? How did you come about the random state 42?
voila. Random states. All right. So here is what you're talking
Yeah,
about.
yeah.
So the random state, it keeps the splits the same every time you run the code. So maybe if you are using,
Default.
yes, it keeps it default. That's why I put it random state 42. So using the same random state means that we get the same results each time we run the code.
Fine. All right. Now, thank you
Yes.
so much. Grady, you mentioned when you were, I just want to chip in one or two things for our audience.
Yeah.
I heard you say cleaning up the data. I would like us to know that no matter what you are doing, it's always good to clean up your data.
Yes. Very
Currently,
true.
I was working with a PhD student, and the data was about 3.5 million. So we're looking for her to even, I'm telling you, over 3.5 million articles. And I'm telling the guy that we should think, he's saying, Dr. Jane is neat. But when we started, we saw, it may not only be duplicates, line strips, there are a lot of things about the data that is unclean. That by the time we finish cleaning up the data and carrying out some exploratory data analysis, come and see the work is half done. So please, I want to encourage us that anytime we're working with data, let's start with clean it up. And you said it. I'm glad you
Yeah.
mentioned it. But when you are doing that, also you mentioned comment. Every stage of Python programming, there is
Yeah.
need for
We put
comment,
comments.
so that the
Yes. Very true.
audience, a layman, can understand who don't even know what you are doing before. You understand?
Very
Scroll up,
true.
you see that when you finish actual the current student versus new, mainly you started classification. You didn't
Yeah.
put comments. You
So
forgot to comment so
this
that
is
they
the
will know.
yeah, this
No,
is the
Dan,
actual
Dan,
code with the
Dan.
comments. Yeah.
Yeah, so that they will know that you've gone to. It was towards the end before your classification. You didn't
Okay.
make a comment so that they will know you've gone to another thing. Go down the more. No, you are going up, down, down, down. You'll see it. You're supposed to tell
Here.
us, yes, that you want to go for comment. Look at, after predicting the exam score,
Mm-hmm.
immediately you started, there should be a comment
Yeah.
for the next stage. Yeah.
Mhm.
I'm glad you are not doing badly. I'm happy I'm here.
Thank you.
Keep it up. Thank you, Cindy. I hope to get the while you share the slide and the rest. I have to run now to continue what I was doing. I'm so happy to be in your midst.
Thank you
Yeah,
so
and I
much for
hope to
joining us
join you.
today.
Yes, please. I'm happy. Eh?
We'll
You are
see you
doing
soon.
well. Thanks so
Thank
much.
you.
So, bye.
Goodbye. All right, everyone. Is there any other question or comment or suggestion for us? Lovely presentation. Thank you so much, Mufaro. All right, have a lovely week ahead. Well, the rest of the week, and do rewatch this on our website, on our YouTube account. We will see you soon. Goodbye.